All right, so we're talking about linear momentum. And last day, I just kind of spontaneously used the words elastic and inelastic as words that we could use to frame kind of like collisions or interactions between bodies. This time we're going to hash it out maybe a little bit more, okay? But I've got linear momentum of a mass, and we know that that's defined as just being P equals m times v. And when we're classifying these kinds of interactions between multiple masses, these system interactions, so not just one body, but multiple bodies. When we talk about classifying system interactions, however, we talk about collisions, and we talk about explosions. And not to be too violent about either of those things, but obviously, one of those could be, like, example, a car crash. And maybe, I don't know, on the adventure side, we could say a rocket. There's all these companies wanting to join the space race in like a private way, right? So like rockets is kind of a thing now even. So the linear momentum of a vector quantity oriented in the same direction as, I should say is oriented in the same direction as the velocity. So we know that idea already, but here I've got these two people, and these two people, they're good friends, person B and person A, and figure 1 shows that they're playing patty cake while on roller skates, as one does, right? So they're sitting on their roller skates. We're going to say that the roller skates are perfectly frictionless, and that's important here for how you play patty cake when you're pushing off of each other. But we'd like to find person B's final velocity. So find friend B's final velocity. Now, as I look at these two people, obviously they're not like equal in mass. You know, B is a little bit slimmer than A, but look at the mass. It looks like A might be twice as massive as B. Okay, I got person A sitting at 0 meters per second and person B sitting at 0 meters per second. This whole system is stationary right now. This would be a good example of an explosion. Okay, so I'm trying to make an explosion, no violence included. Okay, so it's just people playing patty cake. It's all very friendly and like nothing to get upset about or anything, right? Anyway, afterwards we say that person A, the person on the right, is going to shoot off 5 meters per second. Now previously I've pulled out masses that were spring-loaded, and so we could make some predictions. If this person blasts off at 5 meters per second and they're more massive, what do you predict is going to happen to person B? Just qualitatively. What do you say? Yep. Yeah, I'll get shot to the left a little faster. So that's my prediction, right? If the conservation of momentum is going to be a thing. Because what we'd be saying here is that if right is the positive direction, I mean, that's arbitrary. Left is negative. I'm going to avoid using up and down because this is clearly a one-dimensional problem. If I want to find that VB primed, that final velocity for person B, I'd be saying that P total is going to be equal to P total primed. And if I expand that out, as we were talking about last day, that means that I have PA plus PB equals PA primed plus PB primed. And I'm not going to zero anything out just yet. I just want to expand it out for the sake of it because there might be other situations in the future where we can't just zero things out. So I do want to make a generalized equation for an explosion, okay? Like just to make it be something that we have in our back pocket for later and have fully thought out. So I don't want to acknowledge those guys are zero just yet. I want to say, okay, well, we could keep on going. MAVA plus MBVB equals MAVA primed. Notice I'm not priming the masses because the masses are the same before and after, right? It's the velocities that change. And if I was trying to find velocity VB primed, then I'm going to have to get everything but the VB primed term and its coefficient over to the left-hand side. So I'm going to subtract MAVA plus MBVB, and I'll throw in my operation in red. MAVA primed equals MBVB primed. because I'm fundamentally lazy, can I divide both sides by MB rather than rewrite the whole darn thing? I'll do that in red as well, okay? So just so people who are operationally challenged to see what's going on here math-wise, I'm going to divide both sides by MB, thereby canceling out the MB. And the beauty part of this is, where you appreciate this, there's nothing that's squared. I'm going to stop there and we'll come back after.